All right, hi all. This is Mr. Yeager. Our topic today is describing. Oh, there it goes. Dang it. All right. Well, sorry, tough beginning. Anyway, today we are looking to describe motion on graphs. So the last video was about motion dot diagrams, which is one of the simplest ways to show motion. This is again another way that we can graphically illustrate what's happening when an object is moving around back and forth. And so for this one, it's going to be kind of the introduction to how these graphs look, and then we're going to focus on position time graphs with a separate video being on velocity time, and then even probably a separate video being about acceleration time graphs. All right, so when we're trying to describe motion on a graph, okay, there's basically three things we're trying to do. I don't know why 3 is already there, but number one, you're going to want to tell me about the velocity of the object. Okay, you want to tell me about the velocity of the object. Again, we're going to describe velocity simply as positive, negative, or zero. Again, the positive sign being it's going one direction, negative meaning it's going in the opposite direction. Okay, again, positive can mean up, negative down, positive right, negative left. Okay, all it's saying is that they are two different linear directions. Okay, again, we're only talking about linear motion here, or it cannot be moving at all. All right. 2, what would be the acceleration? Is the acceleration positive, negative, or zero? Okay? And then number 3, which has been listed there the whole time, what type of motion does it have? Okay? And now this is one that we talked about in the last couple of videos. There are a couple different types of motion. The first one would be, is it at rest? Is it moving with a constant velocity? Is it speeding up, or is it slowing down? Okay? So those are our big things we're going to be doing when we're trying to describe the motion on a graph. We're going to look at velocity, acceleration, and then the type of motion. Those are the 3 things you're going to have to really be able to describe. Okay? So, when we go back, all right, an object is moving when it has a velocity. All right? Again, I made that big point about acceleration. Acceleration does not tell you that you're moving. Velocity tells you that you're moving, that you're changing your displacement over time. Okay? Acceleration is a change in velocity over time, so that doesn't tell you that you're moving, it just tells you that you're changing your velocity. Velocity tells you that you're changing your position over time. Okay? And again, velocity is a vector quantity, so it can be positive or negative, again representing the motion or direction of motion, while acceleration is how velocity changes. All right? And again, that will tell you whether you're simply speeding up or slowing down, or not, or going at constant speed if there is no acceleration. All right? So again, acceleration does not tell you that you're moving, velocity does. All right? And with acceleration, determining whether you're speeding up or slowing down all depends on whether the velocity and the acceleration are matching. Okay, recall, I could be positive or negative accelerations, but a positive acceleration does not mean necessarily that you are speeding up. It depends on what the velocity is doing. So that's what I have here. Here's your big cheat sheet. Okay, that you have. You can't use it on a test, but this is a good study guide. All right. Basically, what we're looking at is when you have zero velocity and zero acceleration, you will be at rest. Okay. The thing is, it's more that the velocity is zero. I'm going to get my pen back a little bit, so I might be going back and forth a little bit here. Let me get my pen. Boom. Okay. Here we go. So you're at rest, not so much because the acceleration is zero, but because the velocity is zero. All right? You will get some of these questions while you're practicing. Can an object accelerate and have no velocity? Technically, yes. Okay, an object thrown up in the air at the very top of its flight will stop for a moment right before it starts falling back down, but gravity is always pulling on it. But zero velocity, in general, when we do the graphs, that'll mean you'll have zero acceleration, you'll be at rest. If you have positive or negative velocity and zero acceleration, you're going to be moving at a constant speed. When the signs are the same, when the signs are the same, positive, positive, or negative, negative, that means you're speeding up. We will never just say that you're accelerating, you need to describe it. When the signs are opposite of each other, positive, negative, negative, positive, that means you are slowing down. So try to keep that in mind. Again, what we're going to be doing is we're going to go through it and go, okay, tell me what the velocity is. Is it positive, negative, or zero? We're not going to do so much calculation. We'll talk about how to calculate it. but it's going to be mainly very much a positive, negative, zero. Positive, negative, zero. What type of motion do you have? All right. So again, just to kind of review, when is the object moving at a constant speed? That is when you have a velocity and no acceleration. When are you speeding up? When the signs are the same. When are you slowing down? When the velocity and acceleration have opposite signs. Okay, it doesn't matter which one. The biggest mistake people make early on here is they will sit there and go, I thought positive acceleration means speeding up. And I'll go, no, that's not right. Okay? So you got to make sure that you understand it's all about what both signs are doing, not just simply one. All right. I guess we could just do a quick couple practice questions here. If you have a car moving north, but it accelerates towards the south, how is the car moving? So it's saying you are moving north, but the acceleration is south, meaning opposite direction. That would basically, you could say north is positive, south is negative. That means you have a positive velocity, negative acceleration. You must be slowing down. Okay? You must be slowing down. Is that because acceleration is negative? No. It just means it's because the acceleration and velocity are in opposite directions. When a watermelon falls from a tall building, why does it speed up? Because its velocity and its acceleration are in the same direction. You can say they're both negative, you can say they're both positive. All right, depending on what you're considering down to be. All right, so here we go. There are really three main types of graphs out there, and they are all very much related to each other. We'll describe. We're going to have to be able to convert one into another as well. Okay. So you can see we're going to have our distance time graph, our position time graph. Obviously, they have displacement time. All those are the same thing. All right. That's the one we're going to focus on in this video. There's velocity time graphs and there's acceleration time graphs. Okay. We'll just start moving. Well, I'll just say this. If you take calculus, you will notice that basically the graphs should get more and more simple as you go from distance to velocity to time. Okay? That's because if you know about derivatives and integrals, basically velocity is the derivative of the distance equation and the acceleration is the derivative of the velocity equation. Then if you do integrals, you go back up. So we'll talk about that a little bit later on another video. All right. So when you start with a graph, again, eventually you're going to have all three types. Again, this one's going to focus on position time, but eventually you're going to have all three types. And the first thing you have to do is you have to identify the type of graph, because what we're about to go over is things mean different things on different graphs. Okay? So identify the type of graph that you have in the problem. The first thing I would say, you're going to hear me say this about every graph. Does the slope mean anything? What does the slope mean? Okay, we graph things because, as you saw with linearization, okay, for those in the AP class, all right, for those in virtual, you don't have to worry about that too much in the regular virtual class, okay? But for those with linearization, we always usually figure out what the slope means, okay? So slope is very important. From there, break down the motion on the graph by determining the velocity and acceleration of each section. Basically, when the line changes from one type to another, you're going to have to describe a new type of motion. So these problems sometimes take a bit. There's a lot of pieces to them, but you kind of get the handle on it. There is a pattern to them. Okay? So here we go for a position time graph. Okay? Obviously, like I just said, a position time graph is the same thing as displacement time and distance time. Okay? They're all the same thing. All right? First off, just so we don't overlook or make this too complicated right off the bat, it's trying to tell you how the object is changing its position. Okay? So if I look at this bottom graph down to the left here, let me get my pen again. Okay. Let's start off with just being able to look at this graph for what it is before we start breaking it down a great deal. Okay. This is just telling you what the object is doing. So I could say, what does the object do on this bottom graph to the left here during the first 5 seconds? Well, all it did is it went from 0 to 60. So this person moves 60 meters. Okay? What are they doing between 5 and 10 seconds? Or maybe 12 seconds. Okay? Whatever. All right? Up to that point. What's it doing right here? It was at 60. What's it doing over here? It's still at 60. Now, this is where you're already trying to analyze it some. Technically, what did it do there? It didn't move. Okay? So we're going to learn that means you're at rest. What's happening over the last bit of time? You're going back to 0. you're going back to 0. All right? So let's start off with this. Let's start off with some basic questions. It's just, going, how far did it travel? Okay, I could ask about, like we did in the last one, what distance did this graph illustrate the person traveling? Well, they went 60 meters out and 60 meters back, so their total distance is 120 meters. This is a good review. What is their displacement over this whole graph? Did you say 0? Because that's correct. It is 0. Why is it 0? Because displacement is talking about where are you at the beginning, where are you at the end. Well, you're in the same spot, so is there any displacement over the total 15 seconds? No. All right? So that's kind of the first thing. Obviously, be able to just go, how far does something travel? The question doesn't always have to be something very complicated. Just be able to recognize the graph for what it is. Okay? Distance and displacement obviously can be tricky, but those would be the more simple problems with this. Okay? You can see on the right-hand side, there's going to be a lot of different types of lines. We're going to have curves, we're going to have slope lines, and so forth. We'll get into that right now. Okay? So what does a position time graph show you? Okay, I basically probably already went over this. It's simply telling you where the object is at different points in time. So I've already talked about that. Okay, 60 meters away is back at 0 meters. Okay, so we already went over the distance and displacement, so that's covered there. All right. The thing is, this is the more important part. What does the slope tell you? This will tell you about basically how you are moving. Okay, so what does the slope mean? Okay, you've got to think, what does slope mean? Don't overcomplicate. You know what slope means. It means rise over run. It means the y-axis divided by the change in the x-axis. All right, if I wanted to calculate it. The thing is, in physics, look at the graph. Look at what is on the y and x-axis. What's on the y and x-axis? All right, distance is on the y, time is on the x. I know it says displacement. Again, basically the same thing. Okay, so if I'm doing slope, I'm putting the y divided by the x, which is what's happening here. It's distance divided by time. What does that mean? It means the velocity. So slope, this is very, very important. If I had my poor pen here, I would star this. The slope on a position time, distance time graph is always the velocity. All right? In every graph you get, put the y, what's on the y divided by the x. It probably is something that we've been talking about during that unit. So that's going to be something all year long. What's on the y, what's on the x? If I divide the two, is it related to any formula that I've shown you during that unit? In this particular case, distance over time is velocity. Okay? So the slope is velocity. There, at least I have it in bold. Okay? Slope is velocity on a position time graph. On a position time graph. There's still 2 other graphs we're going to do. It's not going to be velocity. It's going to be something different. Okay? So I could ask you, how fast are you going over the first 5 seconds? And so what you do is you just find the slope, and now it's giving me the velocity. So that's another possible question. What is the velocity? Find the slope on the graph. On AP Physics, they don't make these very difficult. Again, you don't need a calculator for the test. They're going to make it something that you can divide in your head. Okay? I would actually say 60 divided by 5 is slightly more difficult than what you'll probably see on most tests. Okay? So, on a position time graph, the slope is the velocity. The thing is, what we want to see is, if you have one slope here, all these are showing you one slope. Again, I'm going to grab my pen. I'm going to be interrupting myself quite a bit. All right. If you have a straight slope line, just like this, or any of these, you have one velocity the entire time. You have one velocity because you have one slope. Everywhere on this line, it's one slope. Okay, any 2 data points, it's going to show you the same change. One thing we want to point out, though, is since it's the velocity, one of the things we want to do with the graph is go, is it a positive velocity or a negative velocity? Well, if the line is going up, it's a positive velocity. If the line is going down, that would be a negative velocity because you're going to have a smaller number, minus a larger number. So it should come out to a negative change. So an upward line means you're moving in the positive direction. The negative line means you're moving in the negative direction. This line, these graphs can go below 0. That's fine. That would just be a negative velocity. Not because you're below zero, but because it's a negative line. It could be below, and you could be going up. This would be a positive velocity because you're approaching the positive side. Okay? So a straight slope line, that's how I usually describe it, a straight slope line, all right, represents a constant positive or negative velocity. And then if you're steeper, the steepness obviously means, you have a greater velocity. All right? Because you might not need to calculate it. It might just give you a graph and give you a couple lines and go, which line shows a car going the fastest, the steepest line. Okay? Don't get confused with the ones when you're underneath. That's a common error. People get confused with when you're underneath the line. So again, what you should notice is upward slope means positive, downward slope means negative. Again, that's just telling you the direction you're going. Excuse me. A steeper slope means faster or greater velocity, and a straight slope line means you have a constant velocity. The slope is not changing, so your velocity is not changing, and so that will mean you have an acceleration of 0. We're going to do a final big problem at the end to kind of make sure we understand how we identify everything here. All right? So, what would a position time graph look like if the object is at rest? Well, if the object's at rest, you're not moving. So on a position time graph, what should you see? You should see a flat line. If it's at rest, the object can't be moving, so it's going to be a flat line. Okay? So a flat line anywhere on a position time graph means you are at rest. Okay? What about accelerating? Okay, how can I show that you are accelerating, that your velocity is accelerating? Sorry, your velocity is changing. Okay? How can we show the velocity or slope changing? Well, if the slope is changing, that means you have a curve. So when you see a curve, that means you're accelerating. Now, don't get worried here. You're not going to have to find the slope of a curve. That's not, it's difficult because obviously it's changing constantly. This is going to be much more qualitative of just seeing it and going, what can you tell me about what's happening to the slope? Is it getting steeper because is the curve getting higher? Or is it getting flatter, so slower speed? Is it getting flatter? Okay? And so again, here you go, basically showing you the big difference. A straight line shows a constant velocity. A curved line is showing you an accelerated velocity, one that is changing. Okay? And we will do what's called a constant acceleration. In other words, it's not multiple accelerations. It's just one acceleration that's causing the velocity to change. But the idea here is, at every single one of these points, you could draw a tangent line to the curve, and that would technically be representing what the velocity is. And the idea is, I'm trying to draw these 4 lines, it's getting steeper and steeper and steeper, meaning my object must be speeding up. Okay, my velocity is increasing positively. I'm already positive velocity, the curve is upwards, so therefore I must be speeding up. Okay, and you'll see that on the next slide. All right. For this one, okay, you can see obviously it's curving downwards, but is the slope getting steeper or more flat? This one's also getting, the one on the left here is also getting steeper. So on the graph, you can see here, it's a negative velocity because the line's going down. So again, line up positive, line down negative. The thing is, the slope is getting steeper, so the velocity must be increasing. The slope is getting more and more negative. So what does that mean? You must be speeding up. In order to speed up, what can you tell me about the signs for positive and the signs for velocity and acceleration? They must be the same. So if I know I have a negative velocity and I'm getting faster, I must have a negative acceleration. Basically, the other one is just telling you the opposite. The line is getting flatter. Again, when the line is flat, you're stopped. You must be at rest, so you must be slowing down if the line's getting flatter. The line's still going down, which means you have a negative velocity, but if you're slowing down, the signs must be opposite, so that must mean I have a positive acceleration on that graph. Okay? So if we describe the velocity, acceleration, and type of motion for this graph, all right? I want my pen again. There we are. Oh, you already saw the answers. Dang it. Well, we'll do it anyway. Describe the velocity, acceleration, type of motion. All right. How would I look at this? It's a distance time graph. All right. It's a curve. Those would be like the 2 things hopefully everybody can notice right away. That means I know I must be accelerating, so there's not going to be anything that's zero. All right? So how would I go about this? I can't just say it's accelerating. That's not a type of motion. Okay? It's not a specific type of motion, I should say. The line is going up, which means I must have a positive velocity. Is my line getting steeper or more flat? You don't need to draw it. You can all probably see it. It's getting steeper, which means what must my velocity be doing? What am I doing? I'm getting faster. I am speeding up. You don't have to necessarily answer these all in order. You don't have to sit there and go, I need to find the acceleration next. All right, you can. Some of you guys will obviously do that very quickly. All right, but positive velocity speeding up, that means my acceleration must be the same sign as the velocity. There we go. That is my answer I'm looking for in a lot of these worksheets you're about to get, okay, that you're going to be working on through this. All right, so that's it. All right, describe the velocity acceleration type motion for this one. All right, it's a curve again, so I know nothing's going to be zero. I have a positive velocity. I'm not going to worry about my pen this time. I have a positive velocity. It wants me to do the acceleration next. Well, let's think about that. I can basically get both answers at the same time. It's steep and getting flatter. Right here, the object would technically be at rest. So that means I must be slowing down. In order to slow down, the velocity and acceleration must be opposite signs. And therefore, there we go, I am slowing down. Excuse me. So the last thing with this all is how do you know when the object turns? Okay? How do you know when the object turns? Well, what do we mean by turns? It means we're going from one direction back in the opposite direction. Back in the opposite direction. All right? Well, in order to turn, that just basically means, oops. You have your other question there. We'll deal with that later. So turning on a position time graph means you must go from a positive to a negative velocity. All right? Well, how do I do that? Well, velocity is the slope. So therefore, a turn in position is seen on the graph when your slope changes from positive to negative. So this, you can see at the very top here, I am turning right now at this point because my velocity has been good, but the slope's always up to this point, and then going back down negatively in the opposite direction. So turning on a position time graph, it has to do with the slope changing directions. All right? How do I know if I have multiple lines? What does that mean? If they cross, when two lines intersect, you can see based on this video here that I have, this little animation. They cross, that means that at that point, they are at the same position. So what's happening there? One object is about to pass another. They're at the same position at that point. So you can see here, basically the red line has a steeper slope. There, that means they're going faster, seen through the illustration, the animation. And that's all it means. It just means the two objects are at the same position. Again, that's kind of an easy, like, just do you understand how to read a graph? If they both intersect at the same area, they're at the same point. Okay. All right, so if we analyze this particular graph, and then we're going to do one more, a slightly more difficult one. Sorry, I want to go back to something. Okay. You can see there, when lines intersect, objects same position. All right, so let's analyze this particular graph. Okay. What we'd have to do here is we'd have to describe every single section of this graph whenever the line changes. If you look at it, one, position time graph. What does that mean? Okay. Well, the slope on it would mean it's the velocity. So if I look at this one, I have one section up to about, 40 with one line. Then I have a slightly steeper line between 40 and 50. I can't read this right, but around that, close to it. Then 50 to 70 is a flat line. Then I have a section from 70 to about just past 90, 90 to 100, 110, and then 110 back to 130. So I need to describe 1, 2, 3, 4, 5, 6 sections. The thing is, this is where some people start getting faster. You don't have to sit there and identify each section separately. Some people like to sit there and go, let me write down all the positive velocities. Let me write down all the negative velocities. Let me write down all the zero velocities. Then you look at the accelerations. All right. Now, one of the things you can obviously notice on this is, do you see any curves? No. So that means, what can you tell me about acceleration everywhere? It's zero. All right. So if I break this one on down, okay, from 0 to 35, positive velocity, line's going up, acceleration is 0, I'm going at constant speed. Okay? From 35 to 45, it's a positive velocity, line's still going up, but I'm going to say it's faster. If I found the slope, which again, the question can always say, calculate the velocity, just find the slope. It has a positive velocity, 0 acceleration, constant speed. I left out, oh, there it is. Yeah, 0 acceleration. 45 to 65, both velocity and acceleration is 0, so you are at rest. Speed this up. Okay. Obviously, you can then analyze the rest of it. Okay, that's basically what we're looking at here. Okay. What distance does a person travel on this whole graph? Well, they're going to travel 60 meters out and 60 meters back, so 120. What's the person's displacement? That would be 0. All right. Again, you can analyze this one. All I would again be careful with is the idea that from 0 to 40, 35, again, positive velocity. The whole section from 50 all the way down to 75, 80, whatever that is, that's all a negative velocity, even after you cross the x-axis. Do not get scared that you get below 0. All that tells you is that you're at a negative position. It does not change anything about how to interpret velocity, positive and negative, and so forth. Okay. Last thing. Okay. When you do get a curve, you can find the average or instantaneous velocities at different points. Okay. Basically, what you have to do is, okay, the average velocity, if they ever ask that, again, average velocity is just what's the total displacement over the total time. That would just be a straight line slope between those 2 points. Okay, it's not even a best fit line or anything. That's what the average velocity would be. Okay, is that what the velocity is the whole time? No, it's the average. It's lower down at the beginning. You're below the average velocity. Above, like higher up, you're above the average velocity. All right, so that's not what the biggest mistake is people think that's the final velocity. No, the final velocity is actually probably double that. Okay, it's most likely double that. All right, because again, it's an average over the time. Instantaneous velocity can technically be found by taking a small slope between any 2 points along the graph. You can basically get like very close points. You can basically illustrate the different instantaneous velocities with like smaller slopes. Okay. All right, so to finish it up on a position time graph, you're going to have to be able to identify velocity, acceleration, and type of motion, and then you're going to have to recognize displacement and distance the object travels. Okay? We're going to look at velocity time graphs on the next video. All right, thank you.